Hey everyone, my name is Luke. I'm a peer tutor here at UGA. I'm a philosophy major. The main thing I tutor is symbolic logic. And if you're watching this video, it's probably because you're in that class right now. So today we're going to go over the concept of validity. I hope you have a better understanding because personally I think it's pretty interesting. So first we're going to define validity. What is validity, right? Validity is the relationship, keep this in mind, between premises and conclusions, where true premises guarantee true conclusions. That means every time your premises are true, your conclusion will be true as well. Ultimately, validity is as simple as that, but what does that mean actually in the practice of symbolic logic? Let's see an example. I put the truth table for the conditional operator up here. I'm sure you've already learned it, but just for reference, to help you understand in case you maybe don't remember. But if these premises are true, and P is true, right? P therefore Q, P, Q. If P, then Q. P, then Q. Definition of validity. Every time these premises are true, this conclusion will be true. Let's look at an example to illustrate it. Say P is I live in Athens, Q is I live in Georgia. It is true. If I live in Athens, then I live in Georgia. So let's say for the sake of this argument, me, I live in Athens, P, which is true, right? Therefore, I live in Georgia. Every single person that lives in Athens lives in Georgia. We're talking about the US, of course. Obviously, semantics can get tricky with logic. But this is an example of a valid argument. And this is going to help us define what ensures validity through a simple representation right here on the left. A valid argument, true premises always give you true conclusion. But how do we show that an argument is invalid? Do you have an idea? Remember, a valid argument has true premises that always give a true conclusion. So how can we show that an argument isn't valid? I have an idea. What if we could show that an argument has true premises but has a false conclusion? Let's give it a go. We can do it actually with this example just by switching these two letters. So on the surface, this might look valid, but it's not. Now I'm going to tell you why. Even if both of these premises are true, we'll grant them truth. P could be true, that's right, but it could be false. And remember, validity is a relationship. It is how these premises relate to this conclusion, a relationship of a guarantee. A valid argument has a guarantee. The premises are true, the conclusion must be. But this doesn't guarantee it. It could lead to truth, but there is no guarantee, and that's why it's invalid. We'll go back to our English equivalent to help you understand. P is I live in Athens, Q is I live in Georgia. So, if I live in Athens, I live in Georgia. It's a true statement. I do live in Georgia, and I do live in Athens. So, hey, this is true, right? But let's say we were talking about someone from Dahlonega, or Atlanta, or Columbus. Then this conclusion becomes false, even though these premises are true. The sentence, if I live in Athens, then I live in Georgia, is still true. This sentence, I live in Georgia, is still true if you're in Dahlonega, Blue Ridge, any other city other than Athens and Georgia. But the statement now that you live in Athens is now false. So now we've shown that this argument has true premises but a false conclusion. And that is how we show invalidity. Okay, so for our final example, we have a fun one. Take a look at this. Stop and think for a second. Pause the video. Do you think this argument is valid or invalid? So what do you think? All right, let's see how you did. Let's look at an English equivalent for an argument about a shape. Let's say P is the shape, has 4 sides. Q is the shape, the 4 sides are equal in length. And let's say C is a square. So we know this sentence is definitionally true. The shape has 4 sides and they're equal in length, and that shape is a square, right? True. So let's say we're looking at this shape right here, right? This shape fits P. P is true. It's got 4 sides. But is the shape a square? No. Therefore, false. On one hand, we could be talking about a shape like this. It's not the best square, but let's say it is one. In this case, P is still true. This shape has 4 sides, and C is true. Has a square. So sure, this argument could be true, but it isn't always. Because we can have a shape with 4 sides that isn't a square. And that's how we know that this relationship does not guarantee a true conclusion. And that's why we know this argument is invalid.